Module 11 talks about capital budgeting. Basically, capital budgeting is a method in which we allocate a firm's resources to equipment, investment opportunities, maybe in other companies, projects of various types. So in this lecture, we're going to talk about what is capital budgeting, the capital budgeting cycle, and we're going to look at some methods of evaluating capital projects, how do we calculate the cost of capital, what is an internal rate of return, and we're going to calculate CapEx. The capital budgeting cycle is as follows, and these are very definite steps that every firm will go through. First, you have to define the process. Tell the managers and the subordinates, okay, how can they submit a capital budget request for something they want to obtain money and funds for. Then you accept and set the accept-reject standards. In other words, we'll accept only projects meeting this particular level of return. You gather proposals from the various sources. You screen those. First, they have to meet the accept-reject standard, and then you have to rank them because there's always more requests for capital investment than you have resources available to them. And then you approve some of the projects, and supposedly there's supposed to be a post-audit to see if the projects actually perform the way that they were projected to be after they've been instituted. Normally the capital budgeting cycle takes place at the same time you're preparing the operating budget, which we discuss in Module 15. The interesting part of this is that we have to set the accept-reject standards. Which projects do we accept and which ones we're going to reject? And this varies from company to company based on their resources and their appetite for risk. Interesting enough, probably more than half, maybe even 2/3 of the capital budgeting requests that are made today do not go through the screening or accept-reject standards. The reason for this, they come from requests to fulfill some type of a governmental regulation. And so that investment has to be made in spite of what else you want to do. So let's say that you're running a paper mill in Lewiston, Idaho, and you want to invest in some equipment that will make your operation more efficient and increase the shareholder wealth. At the same time, you've had an audit by EPA, and they have said that you need new brushes in your stacks. What do you think is going to get funded first? The EPA request or mandate. And then after you have met the various governmental mandates, then you come in and start applying the accept-reject standards that we would normally think as the normal in capital budgeting. Who is involved in the process? Well, probably anybody's involved in the process who has the authority to purchase new equipment or purchase assets to enhance the operation. So it could be somebody as simple as a parts manager in a warehouse, or it might be a plant manager of a multi-million-dollar operation. There are three basic methods of evaluation that are accepted. The accounting average rate of return, the payback method, and the discounted cash flow. And I want to discuss these and show you the deficiencies of each and the positive aspects of each of them. Let's talk about making an investment. We're going to invest $10,000 in year zero. Now, when you're talking about capital investment, the year of investment is always called the year zero. So that is very important to remember. So that over 5 years, 1 through 5, we're going to receive the following cash flows in return. Years 1, 2, 3, we earn $1,000 return each year. In year 4, we earn $7,000. In year 5, we earn $4,000. So for a $10,000 investment, we will earn over the 5-year life of the asset $14,000. And then in this particular example, we have no salvage value at the end of year zero. So now if you think back to our discussion on depreciation, you remember that in some cases you might have a salvage value. If that is true, then we would want to take into consideration the cash that is going to be generated by selling the salvage as well as the cash that is earned using the asset during its life. First, let's look at the payback method. The concept of the payback method is the faster you get your money back, the more likely you are to invest in that particular project. So that's why it's called a payback. So you calculate payback in terms of years. Here's an example. If you look at years 1 through 4, we get a cash inflow of $10,000. Remember that our investment was $10,000. So by the end of year 4, we have received all of our investment back. So we say this has a payback period of 4 years. Now, this doesn't take into consideration the size of the investment or the consequences of the time it takes us to get our money back. It just says in 4 years our investment will return to us. Now let's look at the accounting rate of return. We make an investment of $10,000 in year 0. At the end of year 5, that investment has a 0 value because we said it had a 0 salvage value. So we want to come up with the average investment. So $10,000 plus 0 divided by 2 is $5,000. Now let's say that we had a residual or a salvage value at the end of year 5 of $2,000. So you have $10,000 plus $2,000 or $12,000 divided by 2 or $6,000. Now our return is $14,000 over 5 years. So to get the average return, you divide $14,000 by 5, so you get $2,800. So to get the annual return, you take the average annual return of $2,800 divided by the average annual investment of $5,000, and it says you get a 56% return annually on this investment using this method. Now, what is wrong with the payback method and what is wrong with the accounting rate of return? Both of them ignore the concept of the time value of money. The concept of the time value of money says something like this: the longer I have to wait to get my money back, the less valuable it is to me because I don't have it available to reinvest. So if I have to wait 10 years to get my investment back, it has decreased in value because I can't earn anything on it during that 10-year period of time. It's a concept of the old saying of a bird in the hand is better than a bird two in the bush. The concept of time value of money was first discussed and applied to investment opportunities in a doctoral dissertation by a fellow by the name of Joel Dean at the University of Chicago in 1939. It really didn't get a lot of attention from the academic community until into the 1960s. And then it became a real hot button in academia. When I went to graduate school at Chicago in the late 1960s, Chicago was really high on the discounted cash flow method and the time value of money approach to evaluating investments. And I learned a lot about it at that time, far beyond what we're going to be able to cover in this course. When I finished graduate school, I was transferred to the Spokane office of Ernst & Ernst, the national CPA firm, now known as Ernst & Young. And I did a lot of consulting work with business people. These were primarily small business people. I mean, $10, $25 million a year in sales. And in working with them, I started talking about using discounted cash flow to evaluate their investment opportunities. They understood it thoroughly. Some of these people were not college graduates, they were high school graduates. But they understood the longer you had to wait for your money, less valuable it was. They understood the concept of the time value of money. And interesting enough, when I went there, a client came in with a investment problem. They were sent to the tax department. For some reason, the tax people were supposed to have some special insight as to how to evaluate projects. And they would get the Ouija board out and rattle it around and come up and say, oh, yep, this is the project right here you need to do, without any inkling or concept of how they should be using discounted cash flow. Now today, discounted cash flow is very much ingrained in American business. And even small businesses, and certainly people who are advising businesses, large and small, use a discounted cash flow method of looking at and evaluating investment opportunities and comparing one to the next. So now let's look at applying discounted cash flow to our project where we're making a $10,000 investment in year one, and we have a return over 5 years. Now, first let's digress and talk about how do we set the discount rate. So you have to set a rate at which you're going to discount your money over time. And this is the rate of return that you want to earn if you had the money in your hand. Sometimes we talk about opportunity cost. Economists are great on opportunity costs. This is hard to quantify. Then you can use a weighted cost of capital approach. In other words, you shouldn't invest in a project that returns to you less than your cost of capital. And I will go through an example of that in a few minutes. A third rate is arbitrary. I have found basically that most business people arrive at their discount rate on an arbitrary basis. In other words, they say, we want a 20% return or we're not going to invest in it. Or we want a 25% return. And usually these returns are in the area of 25 to maybe even 30%. You don't talk about 5% or 10% because they're taking a lot of risk in making these investments. And they want to make a good return to their shareholders on them. So now let's look at how to calculate weighted cost of capital approach. Here you see a chart and we have several columns. We're now looking at the long-term liability and capital section of a balance sheet. This is where firms get their capital by incurring long-term liabilities and selling stock and the earnings they retain from the operation that they don't pay out in dividends. So think of these in terms of millions of dollars. So we have $7 million of capital, and it breaks down into bank loans, bonds payable, capital stock, and the retained earnings. And then we have a weighting column, and we have a cost column, and a weighted cost. In calculating the weighting, you divide each component by the total capital. So if you divide $1 million by 14.3%, $1 million by $7 million, you get 14.3%. Divide $2 million by $7 million, you get 28.6%. Divide $3 million by $7 million, you get 42.8%. So if you add those all up, it represents 100% of your capital. Now, each of those components has a cost. For example, your bank loan, the cost of your bank loan would be the interest rate you are paying. The cost on your bonds payable could be what you're paying in interest on the bonds. If you have preferred stock in here, it could be the preferred stock dividend rate. Now, in this case, I have capital stock and retained earnings at 20%. So what I've done here is I've arbitrarily said, I believe that I should get a 20% return on my common equity, or I should not make an investment in that project. So I've selected that rate strictly on an arbitrary basis. So next you want to calculate is your weighted cost. So you'll multiply the weighting by the cost. 14.3% times 9% is 1.3%. 28.6 times 7, 2.0%. And then you add those up. So overall, our weighted cost of capital is just under 15%. So we would not want to make an investment that didn't return at least 14.8% to us. So this is one way at arriving at the discount rate. Now let's take our project and apply discounted cash flow to it. So first we lay out the cash flows. Again, there you see year 0 and years 1 through 5. So at the bottom, our net return is $4,000. Now I'm going to use a discount rate of 14%. And I want you to listen very closely to how I'm going to use this rate. In the back of your textbook, there's a set of appendix schedules. These are called present value tables. One is the present value of $1. One is the future value of $1. One is the future value of annuity. One is the present value of an annuity. So we're going to use the present value of $1 table. So probably you should open your textbook to the table that says present value of $1. Now go over to the column that is 14% and look at the discounted rate. The rate in year 0 is always 1 because we have the money in our hand. We still have it in our hand, so our dollar is still in our hand, and that dollar is worth $1. If we have to wait 1 year to get our money back, we will lose the opportunity to earn 14% on our investment. 2 years, 76%. Year 3, 67%. And so forth, clear down to year 5. So you can see if we have to wait 5 years to get our money back, the money we get in year 5 is only worth about half what it was worth in year 0. And again, the reason for this is we do not have that $4,000 to invest at 14%. We have to wait to get it back at the end of year 5. So this is the concept of the time value of money. If you go down that table, you'll notice that the longer you wait, the less valuable those dollars are because you have to wait to get them and you don't have them available to you to use. So now we want to calculate the present value of those cash inflows and outflows to see if we're getting a true 14% return. So we multiply the cash flow by the rate. So $10,000 times 1 is $10,000. We have it in our hand. $1,000 times 0.877 is $877. So if we have to wait 1 year to get that $1,000, we would be indifferent to having somebody give us $877 today or waiting 1 year and getting $1,000. Because if we have the $877 and we invest it at 14%, at the end of 1 year, we would have the $1,000. And now, when you add up all the present values for each year, you'll notice that it does not meet the 14% return. We are earning something less than 14%. So, if that is our cutoff rate, we would then reject this proposal. And if you recall, under the payoff method and under the accounting rate of return method, both of them were acceptable. But they did not take into consideration the time value of money.